We're trying to solve a problem here.
Tomorrow's going to be very exciting.
We are so excited about the future.
I will build your roads.
We don't need roads.
Hello, and welcome to Solving for Tomorrow, Tales from the Tech Frontier, the show about tackling the biggest problems in the universe with technology. I'm your host, Brian Geisel, CEO of Geisel Software. I'm here with Martin Goodson, CEO and Chief Scientist of the award-winning AI data extraction firm, Evolution AI. Martin has worked in data science and AI for over 15 years on products used by New York Times, Condé Nast, and BuzzFeed. He's also the founder of the London Machine Learning Meetup, the largest community of AI machine learning experts in Europe. Welcome, Martin. I'm so glad to have you on the show.
Hi, Brian. Great to be here.
I'm really looking forward to diving in and maybe even being a little more technical than some of the podcasts that we normally do. But I think we'll also come back up and explain it, give some idea of what that is for listeners. So I think it's going to be a nice mix here. So we like to get into the tomorrow and what the future is going to look like. But we like to pause first and go, how do we get here? So my first question, Martin, is how did you get here? Like, what got you into the field? What got you interested in this at all in the first place?
Yeah, that's a great question. So I mean, I've been into this stuff, since I was a child, really. I've been programming since I was 10 years old. And when I was studying for my exams, when I was younger, I used to go to the library and get books out on AI. I'm talking like 15 years old. That was a long time ago, so there weren't many books on AI, but there were some. And it was just a real fascination of mine. How do you teach computers to think and learn?
That's awesome. Was it so you said you were programming at 10. Was it more the programming? Was it more the math behind AI? Or was it like the programming led you into, you know what I mean? Like, how did that kind of work for you?
Yeah, I was never very good at maths, so to be honest. But I was mainly interested in, I was a kid really, so I was really interested in the science fiction idea that you could teach a computer to think and learn like a human being. So yeah, so I was into that. I've always been really into programming, really hands-on. I worked in academia for a bit, did some research into using machine learning algorithms for understanding DNA sequence. So I did that for quite a long time. I did postdocs and things like that. But again, always really, really technical, really, really hands-on. Led machine learning teams in a few startups before starting Evolution AI.
That's awesome. So from the library books on AI until now, or maybe until you started the company, what's the progression there like?
What do you mean in the field or in me?
Both. How about that?
Well, in those days, we are talking, libraries are often quite behind the times as it was, at the time, and it was still really quite a long time ago. So it was all about kind of good old-fashioned AI. It was all kind of symbolic reasoning and frames, and you probably don't know. This is really old AI terminology, but. So yeah, it wasn't really so much at that time. It wasn't a lot of material about neural networks, for example. So obviously, that's been a thing. And for me in my professional career, I've gone through the whole thing of, random forest being what we were using to neural networks, to deep learning, and now, generative models. And also, I mean, that's really the history of our company as well. We started off really focusing on deep learning, traditional deep learning, LSTMs, CNNs, based a lot of our algorithms on that kind of technology. And now we're moving to generative methods.
So I'm curious, in that time frame, do you think, and maybe you can tell us what your definition is too, but do you think the definition or the meaning of AI has changed through that course in time?
Well, I don't think there ever has been a very good definition of AI. That's
well said.
That's one of the problems. And, should we really, so many of the problems that we have do they come just because in the 50s people decided to use this term AI, artificial intelligence? Because, I mean, most people don't really understand what intelligence is or couldn't really define intelligence. And when you talk about intelligence, you kind of, people start to think about human intelligence. And it's not the only kind of intelligence there is. In the animal kingdom, there's a lot of different intelligence levels or cognition. We don't really talk about animals. You're not really going to talk about, I don't know, a protozoa being intelligent, but it still might be doing some cognition, or a hydra. Really, really simple organisms. They're doing cognition, and lots of animals are doing cognition at varying levels. Humans do it really well, but there's not really. I don't see that there's a hard split between the intelligence of humans and what a hydra is doing. These are like these kind of tiny microscopic animals that they're still doing cognition. They're still trying to find food and fend off enemies and predators and stuff like that.
Yeah. I even think about sometimes the what early eyeballs were probably just sensitivity to light, and if there was light, then maybe that meant food is close or it meant food is far away. And those animals or whatever they, bacteria, whatever what might have been, would learn, like move toward the light or move away from the light. Right. And you can sort of imagine from there, like a process of becoming more complex.
Mm-hmm. You're taking in inputs from the environment, you're processing them, and then exhibiting some kind of behavior. And so, really, I kind of find it annoying that it's called artificial intelligence, because it really should be much more all-encompassing than that. It's much too focused on human intelligence, I feel. And then obviously, 1956, Alan Turing, the Turing test, you start to really, really focus down on human mimicry. And the Turing test is a linguistic test, right? It's really about language. So everything's about language, but really, is that really the core of even human cognition? Is it really language? Is it the only kind of cognition that we're doing? I don't know. This is the philosophical question, but
no, what a great question. Because if you think about it, before we understood language, especially when you're very young, 3-4 years old or 5 years old, when you're able to enunciate it, you can talk about things you remember that happened to you before you had language.
Yeah, absolutely. So my daughter, when she was, I don't know, before she could speak, she hit her head on a table, and she was hurt. And when she'd stopped crying, she stood up and she mimed what had happened, like she'd banged her head on the table. So she knew what had happened and what caused the pain, and she was trying to communicate with us. So she had all this kind of complex behavior going on, but she didn't have language. So I kind of wish that Turing test wasn't the basis of everything, and if it wasn't, then maybe we wouldn't have LLMs now. I don't know. So maybe that's not a good. Not a good wish.
How much do you think it has influenced the development of AI towards language or towards human-like things, as opposed to other sorts of intelligence we might have gotten from it?
Yeah, hugely, I think.
Yeah, I think that's really interesting. The like you said, like the development of LLMs. So you said, like, well, man, it's good though because we got LLMs. So that's true. I agree. But maybe we didn't get thing that none of us can imagine right now, because it never went this other way.
Well, maybe we didn't get, like a human or just human child has a sense of play, and they have a sense of fair play, and they have a sense of empathy. And I think that those things develop before language is really, really there. So maybe the core of being a human is much more to do with empathy and social things than it is to do, more basic social things, you might say in inverted commas, but than language. So we don't really have that kind of emotional side of things. Maybe that's a problem.
Yeah, that's really interesting, because one of the things that I've heard as people study the animal kingdom and this kind of thing is one of the big differentiators of humans, and the sort of the difference in intelligence is how long we stay children. if you think about the animal kingdom and like how early a lion is like killing lechwe or whatever they do, it's pretty young. Like you wouldn't see a 3-year-old human doing that, or whenever it is in a lion's life, right? This kind of like 3-year-old still can't feed itself, right? Or maybe just get whatever, this kind of thing. And that element of playing for 18 years or 15 years or whatever you want to consider it, gives us the ability to learn much faster for much longer. So anyway, I just think that's really interesting what you said about play, because I think it is not unique to humans, but unique in a way to humans, right?
It's definitely integral to being a human being, I think. I definitely, it's not unique. I mean, there's loads of cases of play in the animal kingdom, but it's integral and core to being a human being, I think. It's not core to being an LLM necessarily.
Right. Yeah. Yeah. That's really interesting. We talk about here at Geisel Software, you don't need to engage in Nerf gun fights, but they might break out at any time and you need to be okay with it. Because we feel like we work so hard, we have to be willing to play hard too, and just get that time to just be creative and just be silly. And I think you find such great answers in that span. So tell us a little bit about Evolution AI and why Evolution AI. Why did you go the path that you went? And I'm curious about so many things, but why don't you just kind of lead us into it a little bit?
Yeah, I went to okay. So a long time ago, more than a decade ago, I was working on this startup where we were trying to automate tax affairs for individuals. So we were looking at wage slips and like government forms and stuff like that, and trying to do OCR and extract all the information and then do tax. And basically that failed. It failed technically because we just couldn't do it accurately. OCR works really well when you know where to look on the page for the characters. OCR, optical character recognition, is just the extraction of characters from the page. It's been around for decades, it's been around since the 70s, and it works really well when you've got something that looks like a check, because you know where the check number is on every check. So you go to that place on the check, you extract the characters, and OCR has really high accuracy. It's going to do the job for you. But if you don't really know where to find the information on the page because forms change the layout, or you've got different kinds of forms you've never seen before, whatever, wage slips, which you've never seen before, old-fashioned OCR would just completely fail. So that startup basically we just couldn't do it. We failed.
Yeah, that makes sense. And then with convolutional neural networks, can you give a quick overview for folks not familiar with that, what it is, and kind of how that's doing it?
Yeah, so this is traditional deep learning where you have a kind of hierarchical model where you have layers, and each of these layers is trying to represent the data in the lower layer in a slightly more compact way, but it's trying to find patterns in the data. So in the case of convolutional neural networks for our problem, we are going to, for this problem of text box detection, you're going to read in all of the pixels in the page, and then you're going to try and find where you're going to try and use these representations at one of the level. Yeah, I said it's a hierarchy because you have these layers. So you're going to choose which of the layers is appropriate to be finding the text boxes on the page. And it's kind of complex because large text boxes are going to be at the higher levels and smaller text boxes are going to be at the lower levels. So smaller fonts are going to be different to larger fonts. So it's a little bit complex. So we spent a long time on this kind of research where we had a model that worked really well, but then didn't work so well on smaller fonts. So the weakness also didn't work on smaller fonts, or it didn't work on larger fonts. And so those are the kind of difficulties that you get into. And that's basically all of that research that we did was based on using techniques of object detection using convolutional neural networks. And so that's, we did loads of that kind of work, and we built a text box detector that was really, really good, and we could do good OCR. But then generative models, transformer-based models started to happen, where the idea now is it's not so much that you go through this multi-step process, because you think about these steps, at every step, there would be some errors. So the error rate might be quite low. It might be just a few percent. but because there were so many steps, they all add up, and you end up with pretty poor results. So that kind of step-by-step process was never very satisfactory. The accuracy was never really great. It was good enough to use in production and save some time. It was a useful piece of automation, but it didn't really get the whole job done. It would still need a lot of human intervention to check things. So now with transformers, you have an end-to-end process. You've got some kind of vision transformer that takes in the pixels, encodes the visual information, and then there'll be some kind of language model that will interpret that information and do it all in an end-to-end process. So you're not finding the text and then extracting the characters and then trying to figure out which box is which. You're just doing everything in one go.
Interesting. So one thing that you just mentioned that I think is really interesting for the listener is this idea that it worked great on larger fonts, but not great on smaller fonts. And those kinds of things aren't necessarily the same problems you might run into in a traditional logic kind of programming solutions. And so let's say when you ran into that, for example, did it make sense initially that you were having the problem, or when you figured out what the problem was and you solved it, did you go, yeah, that makes sense why that fixed it? Or is it like, okay, we don't understand, but the model's happy now? Like how do you reason with that as the humans, as you're looking at how the machine's learning?
So the process for us was, for a long time, we had quite good synthetic data. We spent a lot of time creating good synthetic data that we could use to train our deep learning models and also use it to evaluate the models. And the models worked great on this synthetic data, but they tended to fall down when we looked at real data. And we didn't really have a lot of annotated real data. So that, it's hard work to create annotated real data because you need to get a bunch of documents, let's say hundreds of thousands of pages, and someone needs to manually draw in these text boxes around all the words. That takes really a long time. It's a very expensive process. So we tried to use synthetic data as much as possible, but in the end, we realized this was just a waste of time, and we should have just made a really good test set of real world data. There were benchmark data sets, but they weren't really good enough for our purposes. So big learning was we needed to have real world data that we needed to annotate and needed to be of high quality. So we did that in the end. That was very important. We should have done it a lot sooner. And the other thing is that we needed to have good metrics. We didn't really have very good metrics. We were using standard object detection type metrics, but object detection, you're talking about finding a car on an image or finding a cat on an image. Like, you just need to find where the cat is on the image. That's what you care about. Whereas a word, for our purposes, it's not good enough to have a rough idea of where the word is on the page. You need to be exact. It needs to be exact. If you cut off like the bottom bit of the Y, then it looks like a totally different letter. It needs to be exactly around all of the pixels that represent that word. So it's really a kind of different problem to object detection. So I would also say there that just relying on the research literature and using some evaluation metric that is just standard in the field is just not good enough. You really need to develop your own valuation metric, which corresponds to the specific real world problem that you're trying to solve. And we learned that we kind of learned that lesson a bit too late in that project. We should have learned it a lot earlier, and it would have really helped us because it's a natural thing. You just use, everyone's coming from a PhD in computer science, machine learning. They're used to these standard metrics, but it's not necessarily going to do the job for your product.
Yeah. Okay. So that's really interesting. That leads us into an interesting thing, which is today there's so many companies that have been usurped by the LLMs. So many companies have gone out of business because ChatGPT now does the thing that specific one was doing. That kind of thing, I think I've seen a lot in the translation companies got leapfrogged. Mm-hmm. So if you were translating between languages, all of a sudden the LLM is just way better at doing that task than the company that was doing that specifically. But it's an interesting point that you bring up about, well, I have all these tools in the some other researcher worked really hard to come up with this algorithm. I'll just use that one. And it's just not good enough to solve the problem. So how do you make that decision? How do you decide when it's like, look, this is out there, it exists already, let's not waste our time, versus it's out there, but it's not good enough, and this is our magic sauce. How do you make that decision to go forward one way or the other?
Badly. I always get too.
Ain't that the truth?
I really, really get too attached to the algorithms that we produce because it's such a painful process.
Right.
And sometimes it can take such a long time, and so I always get too attached. And then something comes from the research literature, like a totally new thing, and it's very easy to be blindsided by that and not really, that's not going to solve our problem. But really, to some extent, that's right. You need to be focused, but you do really need to keep a good close eye on what's happening in the research literature and what's happening in open source, because otherwise, it's just a disaster to just be too emotionally attached to the algorithms that you've developed in the house when they're just not good enough anymore.
Yeah. And then I think you guys kind of went that way from CNNs to transformers. Mm-hmm. So how did you go, holy crap, this transformer thing is something we need to be in on and we need to start using those? How did that happen for you?
Yeah, I mean, so some transformer-based methods came out, some open source methods, which were just blowing away all of the traditional methods on these kind of document extraction tasks. It just became really obvious that we needed to get on board with the transformer-based methods, generative methods. And I'm talking about pre-LLMs, like pre-GPC4, pre-GPC3. So there were some methods out there that we were using transformers. I mean, the other thing is that we had, I don't know how to put this delicately. We had someone in the team who was really against using transformers because of the computational complex, like the computational hit, like how much energy, how much compute that we were going to be using. It was going to slow everything down. So
can you just talk about that for a second so people understand it?
Yeah, I mean, the problem is that lots of traditional deep learning, I think transformers are quite slow is really the thing. So they really need a lot of compute. They really need GPUs. So you need to be running a lot of GPUs in production. That's a big overhead. And it's just a different technology that has different requirements and different trade-offs. So there is a natural tension and a natural kind of inertia in an organization that you just don't want to make this massive change because you've invested everything in this other way of doing things, but eventually you just have to make that decision. You need to do it clear-eyed, and you shouldn't make it emotionally, really.
Yeah. And I think for organizations, it's always this balance between always jumping on the next new thing and getting lost in just never producing anything because you just keep jumping, versus wait, the next new thing really does solve our problem or makes this better or solves it better, and this one is worth the jump. And I love your answer earlier. Like, how do you do that poorly? And because in advance, like as we even here trying to look out to what's the future look like, there are things you're just going to miss. There are things that just look ridiculous, but work great, and things that look great and work ridiculous.
Mm-hmm, mm-hmm. Especially, I think there was a bit of a problem in the literature, or there has been in the past, where the benchmarks were not very good, or the benchmarks had a lot of data leakage. You couldn't really rely on them. So just like taking a paper at face value, just because it had good benchmark work results, that wasn't enough. You really had to do your own work. So it was quite a lot of work involved in investigating a new technology. There was a time where you just couldn't really believe any of the benchmarks at all in papers. And maybe we're still in that time, I'm not really sure, but it's problematic.
Yeah. No, I love that. And I think that's one of the things that's giving you guys the advantage that it has, because too many folks are just, well, this paper came out, therefore it's true. And yeah. And that deep understanding, separate it from deep learning. But that you, the humans, do to go, wait, what is actually happening here? What's really true? How is it better or not better? Or what's happening? Like you said, like the benchmark doesn't just mean it's true. We need to understand it inherently. I think that's really interesting. And you guys have gotten into maybe one of the hardest things is we talk about machine learning and the probabilities and when it's wrong and how often it's wrong and all these kinds of things. But you guys are going into financial stuff. So how did we go from, let's take a thing with probabilities and let's go into something where I don't know, are we never allowed to be wrong? How did you get there, and how do you deal with the accuracy side of things?
Good question. So yeah, our customers would like it if there were no errors ever. Of course, we would love it if we had no errors ever. But what I always say, something very important, which is that the evidence is that humans, when they're reading documents and transcribing that information into Excel or something, they have about a 1% error rate on a field level. Okay. So which is huge. So let's not kid ourselves that humans do this perfectly. Humans make lots of mistakes. So I think I would say that we're roughly at that level now with transformer-based models. So we're on par with humans. There are still errors. Obviously, the more data you have, the better the models and the fewer errors there are. But the most important thing for us, which is integral to our product, is that we need to have a very good sense of uncertainty about any given prediction. So by prediction, I mean just any extracted data point. I mentioned bank account number earlier. That needs to have a confidence score associated with it, which says, yeah, we're really confident, 100%. We're right here. Or maybe we're only 50% confident. That this is so important, because ultimately, if we're not that confident about an extracted data point, it needs to go to a human who needs to check that data point.
Yeah. And I love your point there. I think is really interesting that people don't realize is that this part will sound pretty obvious, but humans make mistakes. But even in numbers things. So I had this friend who was working at a bank, large bank, where they're handling wire transfers and millions of dollars of wire transfers. And this friend got accolades because she made one error in 3 months. And I was like, wow, like, hey, that's great. That sounds awesome. And then had another quarter where they made 0 errors. And I was like, put it in perspective for me. Like, what's average? And they were like, oh, average is 2 errors per day per person.
Yeah.
Unlike, oops, sorry, instead of 10 million, I transferred 100 million out of your account.
Yeah. It's a big deal. 1 0 is
right?
1 0. And that's just the kind of errors that people make, actually. They add digits. They duplicate digits. So adding a 0, taking away 0 is exactly the kind of errors that humans make. So yeah, but I don't think people are really fair, because they're not really fair to machines. I think people think that machines are not going to have any errors ever, and so they put machines to a higher standard. We actually went, oh, this is terrible, but we went for a kickoff meeting at a bank, a big bank, one of the biggest banks in the UK. Well, it was kickoff for a project to extract some information from these documents. So I won't go into the details to protect anonymity, but the big guy. The big cheese over there at the bank, who was really, really senior. He sat there, and during the kickoff meeting, he gave his speech, and he said, we're really excited about this project to use AI to extract this information, because computers don't make mistakes. And on our side of the bench, we just burst out laughing because we thought he was joking. And on their side of the bench, on their side of the table, nobody laughed, and they looked at us like we were mad. And then we realized that he wasn't joking. And so it was a communication problem that, we shouldn't have laughed. That was an early days mistake that we shouldn't have made. But now we think it's really important to make it clear that machines do make errors, and errors is an integral part of the process. And you really need to plan up front, how are you going to deal with errors? You should be doing that with the human process as well. They don't do as much planning around errors for the human process, but they probably, they're equally should.
Yeah. And in fact, I have to do it with one of these too, but there's a problem. My problem is you have it at home and I have it at home, and we all look at it and go, this is ridiculous. Like, how can this problem still exist? And talking to this really big company that solves it. And I said, yeah, what's up with this? And they said, oh, actually, the reason you see that problem is when we throw an exception in our process and we go, look, the compute stopped and went, something's weird here. And the human comes in and corrects it. And the human does something like add an extra zero. And then you get this completely ridiculous result. And you're like, I thought this really smart company was fixing this. They're like, it's actually usually the people, because somebody fat fingered a response or this kind of thing, entered the wrong code in or whatever. And now the corrective response by having the human come in every once in a while gets it wrong. Most of the time it fixes it, right? But every once in a while it gets it wrong and you get this ridiculous result. And so then all of a sudden we're like, how can you get this? How can your algorithm get this wrong when actually it was a person who got that wrong?
Exactly, because humans don't have this confidence score. You know, if humans had a confidence score, you could use that. You could say, well, okay, maybe you made a mistake. Let's get someone to check that. So that's the good thing about using AI for this. It's very important. I think you got this confidence score. It's supposed to tell you how confident you are in one of your predictions, and I think it's amazing.
Yeah. How much of an issue do you think that is, or how do you think that process will go? Because I think we need to go through, like, as a society, we got used to computers were always right. Like, in that sense, like, I know why you all laughed. I'd have laughed with you. But from the banker's standpoint, where they're like, hey, or whoever it was, where they're like, yeah, computers are always right. Computers have always been right. You never put in 3 + 3 and you get the wrong answer out of a computer. But now with AI, sometimes you do. And we're getting, we're shooting for things that are going to be more accurate than humans, maybe way more accurate than humans. And yet it's not 100% accurate, which is what we expect from computers. How do you think that expectation, have you guys run into dealing with that expectation?
Absolutely. I mean, now, we're moving towards, so I said we started with deep learning. We then moved towards generative models, like transformer-based models. And now we're moving towards LLMs. So that's a different thing now. LLMs are based on transformers, but it's a different thing to some of the transformer models that I was talking about earlier. So now, obviously, you have hallucinations. So everyone knows about hallucinations, but they're still surprised when it happens, I think. So if you just upload an annual report of Shell, a big company, public company, into some OpenAI Anthropic thing, then LLM, then and just ask it, give me all of the balance sheets, then it's going to give you a really good looking balance sheet with loads of excellent data. But there's almost certainly going to be some hallucination in there that's going to be very difficult for you to pick up. So on a cursory analysis, if you just eyeball the results, it looks great. But actually, it's just created a line item that doesn't exist on the page. And sometimes that line item is absolutely perfect, and it's exactly what you would expect. For instance, it summed some of the numbers on the page and created a total that just doesn't exist there. So that's kind of innocuous, you might think, but actually it's really important, because obviously this is a regulated thing to have a balance sheet that's published by a public company. You can't just make up line items. So that's a real problem. Hallucination is a real problem, but that's not the only source of errors that LLMs have for this specific problem. So this, I don't know how deep to get into the weeds here, but
can I ask you a question about the hallucinations first? So for anyone who's not as familiar with AI, we've been talking about LLMs in society here a lot lately, and hallucination happens with things like ChatGPT or Claude or Gemini. They're all these big LLMs are doing it because they're trying to predict the next most likely word that you're likely to expect as a human. And that word may or may not be true. It will look true. It will look like the thing we're expecting as humans, but it may or may not be true. And so we talk about it as a hallucination when occasionally it's not true. More often than not, it's true, but occasionally these things will be not true. I'm curious about how we're fixing that. We're starting to see things where you're getting sort of filters or these additional things added on kind of outside of the LLM or on top of the LLM, if you will, to fix it. Do you think we'll we'll end up fixing hallucinations? I guess, do you think we'll end up fixing hallucinations? And if we do you think it will be strategic things around the LLM, or do you think we'll just get the LLM better and better until that's not an issue anymore?
Well, I'm not very good at predicting the future, but where we are right now is I think we need a domain-specific solution. You need to look at your use case and think, what kinds of checks can I do on this data that's been produced, and some kind of checks and balances, some heuristics to make sure that the data is correct. In our case, we're looking at financial statements. So often we're looking at financial statements. So balance sheets are supposed to balance. There are some various financial aspects of it that are supposed to be true. So you can do some of those checks. You can also cross-check it with other kinds of algorithms. We've been building these kind of data extraction algorithms for years now. So we've got lots of things that we can use to check that the answer is correct using some other method. So it's all domain specific. I wish I had like a generic solution to this, but I think you have to look at your use case. You need to be intimately familiar with the domain, and you need to apply something that's very domain specific. Of course, it would be great if there was another generation of LLMs, which are 10 times bigger than the existing ones, which maybe will not hallucinate so much. I mean, it's possible, I guess, that it's an inherent problem with this transformer-based method, and I'm not sure. I don't think it's clear yet.
Yeah. Have you, by the way, have you seen with OpenAI, the O1 preview yet? Have you looked at that at all yet?
I haven't looked at it actually, no.
It's really interesting because it is starting to do things that appear to the human as logic. Mm-hmm. And so it's actually, and you can have it show the steps as it goes through things. It's very interesting because the steps that it show look very human-like.
Great.
Right? Which might just be what the LLM is outputting for the humans to understand it. But it is going through things like looking at this step, looking at that step. One of my favorites to ask ChatGPT to get it to hallucinate is, what's the first 10-digit prime in E? Mm-hmm. And now that exists on the internet enough that now I ask it something else, like what's the 9 or what's the first 11-digit prime in E? Mm-hmm. And it's a very difficult number to compute and find. The LLM is very happy to spit out a 10-digit number and just declare that this is the answer.
Yeah, absolutely.
And the number is not even prime. It might not be a number in E, whatever,
Mm-hmm.
right? It's just spitting out a number. So with O1 preview, I asked it, and of course it tried to give me an answer, and I kind of challenged it. And it's the first time I've ever gotten ChatGPT to come back and go, actually, this is a very compute intensive problem, and I don't think I can get the right answer for you. And I was like, that is the right answer.
Yeah, in your case, but it probably just spits out that whenever it can't figure out what the answer is, and it just happens to be true for your problem.
So I want to go back to when we first started talking about hallucinations. If you happen to remember, you said the other problem, I don't know how deep we want to get into the weeds. Let's get into the weeds.
Okay.
Do you remember what that was you were about to mention?
I do, because I bang my head against these problems every day. So the problem is LLMs are very heavyweight. They're slow. They're very costly to serve. So the vision encoders tend to be of low resolution. Okay, so most of the commercial models that you see out there, they accept images of low resolution. Low resolution by the standards of people like us who are dealing with documents. So we are dealing with very high resolution images because fonts and text tends to be quite small on a page. It has lots of high frequency content and high frequency information. So if you take a low resolution version of a document, you're not going to be able to read it. A human wouldn't be able to read it either without a lot of contextual knowledge. So this is really important that you have this high frequency information, that you have high resolution images. So that doesn't fit very well at the commercial LLMs which are available right now, because they're all working with low resolution, because of the vision transformer and the computational complexity, problems. So that's a real problem for our domain. It's a real problem. So you will see, the OCR rate of a commercial LLM, the OCR error rate of a commercial LLM is worse than traditional OCR, Tesseract type OCR open source methods that have been around for years. The characters will be read out incorrectly not much of the time, but there will be an error rate where the digits might get mixed up, might get switched, or they might just be read out incorrectly. So a lot of what we're doing is figuring out how we can use these low resolution images, extract the data, and then kind of recombine the information. And it's really non-trivial to do that. So that's a limitation of the current generation of LLMs. But the other issue is that LLMs have very poor spatial awareness. So they're not very good at knowing whether, so I mean vision transformers really, so I'm talking about multimodal LLMs. They're multimodal because they use multiple modalities. They use vision, images, and they also use language. So the issue is, so there was this, there'll be quite a few papers talking about the spatial awareness limitations of multimodal LLM. So there's a paper called Vision Models Are Blind. There's another paper by the Lava team, the Lava VL paper, where they show the vision models are just not very good at doing very simple things that humans find really easy, like showing it two circles and asking whether the circles intersect. For a human, it's very, very simple. You have 100% accuracy rate for humans. For these vision models, it's about 60%. So it's terrible. It's terrible, and it's not. I don't think it's well understood by the wider world that there's this big limitation, spatial reasoning. So, if you upload a cat and say what's in this image, it's going to say there's a cat. It's good at that kind of stuff, but very fine-grained stuff where you really have to have very fine-grained spatial reasoning, exactly the kind of problem that we deal with, then it's really not so good. So it has great contextual knowledge. LLMs are really good. They actually understand finance. So it's a big difference from your convolutional neural network who's just understanding pixels. They actually understand finance. So they can understand a document. They understand the contextual stuff. They know about laws. They know about how you do accountancy and how you conform to some regulations about representing financial data. So that's amazing. Like it's really breathtaking. But there are these limitations to do with spatial reasoning, which make the problem quite complicated.
Yeah. Why is that?
I think it's one of the limitations of the vision transformer. So the original vision transformer paper actually did a bit. Well, some of the early papers are surrounding that original vision transformer paper. They did show that spatial reasoning was quite weak for this transformer. It just doesn't encode that spatial information very effectively. And even in those early papers, they were showing that you could try and add spatial awareness using these things called like positional embeddings, positional encodings, but they just didn't work very well. They didn't really improve performance very much. You could just turn them off and it wouldn't really make much of a difference. The model was just not able to use the spatial information very well. So it may be an inherent problem with vision transformers. I wouldn't go that far. It's possible, but I don't really think that's necessarily well evidenced. But it may be just something to do with the implementation that you have to tile the image. So once you tile the image, in other words, you take small fragments of the image and put them all back together again, you lose some information about where exactly things are in the image. So that's what I'm talking about. You just don't know where the thing is on the image. The object that you're looking at, you don't know exactly where it is. That's the problem.
Right. And so I'm curious about with transformers, to dig a little bit into the weeds on some of this is kind of interesting, I think, is on a CNN, you have these convolutions that kind of run first and feed data in that we process. Do you have the same kind of process on a transformer?
The difference between the vision transformer and the convolutional neural network is that the vision transformer kind of learns something. It learns to represent the data. So it could learn to be a convolutional neural network if it wanted to. But it learns the representation rather than a human programming a CNN with all of this kind of background knowledge about how the brain works and thinking this is the way that I'm going to represent this data. You don't do that with a vision transformer. You just give it loads and loads of data and let it figure out the best representation of the images. So it only works if you've got massive data sets. So that's why it's more effective, but also why it's limited. It only works if you have these really large data sets.
Yeah, and it makes sense why it would take a lot more compute then too. Mm-hmm. Yeah. Oh, that's very interesting. Okay, so from all of those things, I think, and both where evolution AI is, but then also as the former chair of data science and AI at the London Machine Learning Meetup, it gives you a unique perspective. And I'm curious, where do you see things headed? Do you think we continue innovating on LLMs? Do you think we move towards something new that is invented but relatively unknown so far, or hasn't been invented yet? What's your projection into the future without necessarily knowing the answer?
No, I'm really bad at speculating about the future, and my predictions are always wrong. So I don't want to try and predict anything, but I would say, in the short term, what I love and I'm really excited about is the fact that open source models are catching up. There was a time when it was quite worrying, I thought, not just commercially, but just thinking, are we going to get to a point where you just have like one or two really big players who have these LLMs and they kind of dominate everything? All the jobs, all of our professional jobs, white collar jobs, get turned into LLMs like that you submit to one of the large tech companies. I don't think that's true. That's looking very likely anymore. I think the open source models have really caught up amazingly quickly. It's really, really exciting. So I'm really, really happy about that. And I hope that trend carries on. As to whether something's going to take over, I think it's impossible to tell at this point. There's definitely nothing on my radar that makes me think this is looking likely. So I'm really, really excited to see what else is going to happen with this technology.
Okay. Yeah. Makes a lot of sense. Okay. And then if you were to have a magic wand to propel the industry forward and you could just solve any problem you wanted to for the industry or for a particular problem, what would you point the magic wand at? What would you just go click your heels and solve?
Well, on the technical side, I would love it if we could have multimodal vision models which had, really good spatial reasoning and worked on high resolution images. But that's the kind of quotidian thing that obsesses me at the moment. But in a wider context, I think what we really need is really well-trained people who understand how to work with this technology and make products from it. I don't think that we have a lot of people who we are readily employable that we can, who have this kind of knowledge. And I'm not really talking about how to train GPT-4, but I mean, do you have good data analysis skills? You understand how to evaluate models. You know how to take a skeptical view and use data to understand how to turn what is just a theoretical, it's just a paper, an academic paper. How do you turn this information, this new technique, into something that you can actually use in a product? I think those skills are still lacking, and I'd like to see them more widespread in the industry.
Yeah. And I think this is the thing when everyone talks about, well, they're taking all the jobs. Technology always transforms the thing that we as the human race need to do next. And it always transforms it to something that is more purposeful. From I move a widget from the left side to the right side of the conveyor belt to now I have to do something more purposeful. I think that's a great next step in kind of that evolution. It's like you said, like, okay, take it from the theoretical and bring it into practical so we can make products and actually use something out of it. I think that's a great place for us to be transitioning jobs into, to solving those problems. One thing that you said about the spatial reasoning is like, this is why it's a magic wand. We just wave the magic wand at it and it's suddenly solved. If we'd had that, if we had multimodal models that had good spatial reasoning and these kinds of things, what kind of problems get solved? If we had that magic wand, what does our future look like after we've solved that problem?
Well, I guess I wouldn't have to go to work anymore. But then again, I wouldn't have a job. I wouldn't have any money either. So because I'd be replaced, But if we had this, then you could basically automate a lot of business processes that are document based. I think most business processes are document based, so I think that's pretty wide. I think it's fair to say that there was a lot of excitement when ChatGPT came out that it was going to automate lots of stuff. I don't think that's really happened yet. I don't think that in the enterprise, in big industry, in large companies, lots of stuff has been lots of business processes have been automated, and it's because of these nitty gritty issues. People need to pay attention to these nitty gritty issues. Once you solve these problems and some other problems, you can start to really automate the whole process, and that's when we're going to see really disruptive change. I don't think we've seen it yet, and it's partly because of these kind of issues.
That's really interesting. Okay, let me characterize it and you see if I got it right. Is today, I think the LLMs and a lot of the use cases for AI generally are helping the people do it better. And if we had some of those things in place with your magic wand today, they might actually be able to do the whole task themselves instead of just helping the person do it. Did I characterize that all right? Yeah. I think that's a pretty cool future.
Well, we could talk for another hour about the social impact of that, though. We're not going to squeeze that into the next few seconds.
No, indeed. So super interesting stuff, Martin. Thanks for taking the time to chat today. I love the stuff that you guys are doing. I love where our magic wand is heading the world, and I hope we can get there together.
Thanks for having me. Been great, really interesting.
Yep. So Martin, last thing, can you just tell people if they want to find you, if they want to find out more about Evolution AI, where do they go? Where do they find that? What kinds of things might they want to find you for? Sure.
Yeah. You can take a look at our website, it's evolution.ai. But I'm really happy to have a chat with people on LinkedIn. I'm on LinkedIn, Martin Goodson. So I'm happy to get connected and talk more about these issues. These are the issues that I find really interesting to talk about. Love talking about.
Perfect. Thanks so much for spending the time, Martin. Really appreciate it. And great chat.
Thanks, guys.
This interview shocked me.
Did it?
Yeah, I think...
I'm shocked that you're shocked.
I don't know how to answer to that. So
you seem stunned that I'm shocked that you're shocked.
Yeah.
Tell me more.
I'll continue. I think it shocked me because I think out of all the interviews we've done so far, all the episodes we've released so far, I think this might be very close to what you're doing or what you're potentially going to be doing. So I know it was an interesting topic for you. So I kind of want to dive into that a little bit, right?
Yeah, I think we talked about AI and machine learning and deep learning and some of the topics in a little bit more depth than I think we have before, maybe?
Yeah.
Is that true?
Yeah, I think it is. And I think it was a new space for me too. I mean, it was not that new because some of the things he was talking about I'm familiar with, but it was a new space for me. And I think one thing that caught me off guard is deep learning. For the non-technical people, can you explore that a little bit? And, what you think about it, and in that context of what Martin was saying, how it works for him and how you've used it, by the way.
Yeah. So, okay, here's one of the things I think is funny in the machine learning world is that we get so used to terms like deep learning. When you use the contrasting terms, people get confused. So like large language models. When we talk about small language models, people think you're joking.
Yeah, because it sounds unreal.
Yeah. So anyway, there are small language models. They're like large language models, but they're trained on more precise data.
Right.
And so they are smaller and sometimes more accurate, or at least more accurate for the things they're on. So deep learning, there's something, most machine learning, I don't know if that's true today, but generally machine learning was shallow learning. And so shallow learning is when you learn directly from the data, which sounds crazy. That just sounds like learning. But when we talk about ML, shallow learning is it's taking in the data points, let's say the temperature of the motors powering the engine that generates electricity at a power plant.
Okay.
And so one of the things they found is oh, when they get too hot and they stay hot, they tend to fail.
Okay.
Someone did that with machine learning. So they tracked the temperatures and they tracked all these different parameters in the power plant. And they finally found these ones around temperatures around the motors. When the motor stayed high too long, then they went, hey, that motor's going to fail. And they were able to start predicting it.
Mm-hmm.
That's amazing. That's shallow learning.
Okay.
So it's learning directly from the temperatures.
Mm.
What happened in the machine learning world is we wanted to do images.
Mm-hmm.
And if you think about the data in images, an image is not a data point.
Mm-hmm.
When we create an image, we actually create pixels. And all these pixels, we talk about 4K and how many pixels are in 4K.
Mm-hmm.
And 4K is almost 4,000 pixels across.
Mm-hmm.
Like 2160 pixels down, multiply those two numbers. That's how many pixels are in a 4K image, just one image. And we're talking about a video. If you want to have machine learning process a video, it's so many images, video, right, being 60 images per second or 30 images per second. It's all this data. That's way different and way more data than the linear thing, like a temperature sensor on a motor. And so what deep learning is doing is it's actually building layers in the learning, if you will. And so that first layer we'll say is the actual data, the pixels.
Yeah.
And then we're going to do something and we're going to turn those into layer after layer after layer. And then in fact, with things like convolutional neural networks, I'm sorry, not to make this more convoluted than the answer had to be, but with those, we're actually doing things to the image like detect the edges on the image or make the image just grayscale, different, like just give me the brightness levels. Or so we do these different things. We call them convolutions on the image. And then we actually feed those into the neural network and have it learn from those. So in a sense, it's not even learning from the actual pixels. So deep learning is just any kind of machine learning where it's layers or more than one layer. When we talk about neural networks and we're doing computer vision, these kinds of things, they tend to be many, many layers. And so in the case of any kind of deep learning, it's more than one layer. Shallow learning is what lots of ML is out there. We don't talk about it now because we have all this stuff we're talking about with computer vision and the way the LLMs work and those neural networks and all these kinds of things. But shallow learning is a very normal thing in machine learning. Deep learning is just when you do different multiple layers, and this is one of those things as GPUs have gotten so much faster, all of a sudden we're able to process all that information. We just didn't have the compute to do a lot of those things before.
It's a little bit more complex. I'm still trying to wrap my head around it. And I think one of the things that I was listening to, or when Martin was speaking, was that it's new. I mean, the time where he went to the workshop, it wasn't that, it wasn't that, it was a long time ago. That's what I meant. Right. Yeah, it wasn't.
Yeah, sure.
So I'm like, I wonder if deep learning is still new. Like, even though he went to the workshop like ages ago, is deep learning still a new phenomenon in the ML world?
We are going to light up the comments at this point because any answer we give, someone's going to be very angry with it. Someone is going to tell us that in the 1940s they had all of this and nothing new has been invented.
That's the thing about like ML that I'm still learning. Like, it was still there. Like, AI is been there for a while, but it's also new. So I'm guessing in this case it's kind of like that.
Yeah, so it's interesting because this happens a lot in science, I think, is where we knew things about space, new stuff.
Right.
Copernicus taught us that the Earth was not the center of the universe. In fact, the Earth goes around the sun. So we knew that a while ago. But then with things like the Kepler telescope and the Hubble telescope, and we've been able to discover more things figure out things like dark matter. And so we knew so much of the math of the universe, even Einstein, from Einstein's time, we knew so much of the math and how things worked. But then when we actually discovered them and we were able to get technology that let us explore them more deeply, then we came to greater revelations on those things. So the same kind of thing happened with the machine learning stuff.
My other question is, he went to this workshop, right? This deep learning workshop. I don't know, like maybe 20, 30 years ago. I think I lost that part, the time he went, but it was a while ago, right? And back then it was new. I wonder if it's still new now, in the ML.
Yeah. Listen, Harry, this is going to blow up the comment section because no matter what we say, somebody's going to be mad because somebody's going to say this was invented in the 1940s and we haven't had any new math since then. It's all the same.
Mm-hmm.
And somebody else will say, no one explored any of this until we had GPUs that could really do heavy compute.
Okay.
And so both are true.
Right.
And it's a little bit like the astronomy. Einstein came along with relativity and gave us so much more information about the universe that we were barely able to prove in Einstein's time.
Mm-hmm.
And then as we got better telescopes, we got the Hubble, and we learned so many things from the Hubble.
Yeah.
There's this beautiful shot in the Hubble where they just pointed it at empty space and let it just sit and overexpose itself to empty space.
Mm-hmm.
And this image is just full of all these galaxies, and it's amazing.
Mm-hmm.
We learned so many things with the technology, even after we had the math.
Right.
So it's the same kind of thing, in my opinion, in the machine learning spaces. Yeah, we had a lot of the math for this,
Right.
but somebody was sitting around one day and went, what if we just don't have enough training data? And they just started feeding training data. Seems like it's always graduate students doing this stuff. What if we just start cramming training data into this thing, and then we train it on a ton of data?
Yeah.
And they did, and all of a sudden it was way better. And so then recently, we've had transformers for ages and ages. So LLMs are built on transformers. If you start looking into LLMs, you'll hear the word transformer a lot. And we had the math for them, but nobody used them. And what we found out is if you look at this graph of how learning went over time, from not over time in years, but as you train the algorithm, you'll see the traditional algorithms go up faster, and then they eventually plateau. They don't get much better. And here is this line where is as much compute as we really had. Now, as the compute got better, we could go past that line. We could do more training. And I think it was somebody at Google that went, let's try these transformers and just keep training them. And it turns out if you give transformers enough time, they get really good later. We just never had the compute for it. And so all of a sudden, everyone's like, wow, these transformers are amazing. And they're brand new. They're not brand new. We couldn't use them before.
Right.
It was just sort of a useless algorithm, right? That's probably a little too harsh, but like at the time, we just didn't have the compute to make them a really good algorithm. Now, all of a sudden we have the compute and it's like, oh, whole different world. So a lot of this stuff, the math, things have been invented long ago,
Right.
but I think that's in a sense irrelevant to the technological advances that we're making today. If that makes sense.
Yeah. I still didn't get my answer. Is it new?
Tell me.
Or is it old?
Yes.
I agree with that. But I think the next thing that I want to point out, and I don't know if our listeners or viewers even caught this, but I think one thing that in the tech field, right? I'm coming into this business or this field. And I think one thing that I'm learning is that you need to be ahead, right? When I say ahead, I don't mean scrape the bottom of the barrel and abuse people to get ahead. No, I mean like you need to be finding new things.
Yeah.
It's a field that encourages that. And I think listening to Martin, that's something I noticed that he did too.
Mhm.
You know, a lot of our episodes, or a lot of our audience, our guests, sorry, let me take that back. Okay. A lot of our guests, right, that come on this episode, they're always also inventing new things, or they found a problem and they were inventing. I think my thing that I want to throw at you is that Martin went to this.
I ducked for our audio listeners.
You stopped my thinking midway. Hold on. Martin went to this deep learning workshop or seminar, right?
Yeah, with like 30 people.
Yeah. And then he made a joke about how now it's like 30,000 and everybody's chasing after this thing.
Yeah. We were at AI Summit last week in New York City, and there's
so many
the
people.
governor spoke.
Oh, really?
Yeah.
Oh. You see, that's what I'm saying. Like, but everybody was like not into that. Like, I remember my friend saying ChatGPT just came a year ago, and I was like, no, I was told it was there for a while. It was working in the background. Nobody knows. So I think for me, if I wanted to start something, if I wanted to research something, how can I be part of that 30 people workshops? Like, you know, as a CEO, like, what do you think people should be doing right now to be chasing that? You know, to be chasing the new invention, or to be part of that new communication?
I think in a way that's very uncomfortable to people and harder than we think, you need to be willing to fail. Because the first meeting of 30 people you go to, it's not going to be the next big thing.
Right.
It's going to be totally useless.
Right.
And the second one that you go to with 12 people, it's going to be even worse. And it's even a little hard to know which one is interesting. Right. I don't know if you went back to that meeting of 30 people, if any of the 30 people there would have told you, would have had the foresight to say, in X number of years, we will have sufficient compute that we could do this at a scale we can't imagine today, and it will solve way more problems than we think. But they were curious.
Right. Martin did say, he was like, I just wanted to learn. I was like, deep learning is so nice. What is it about?
Yeah.
I was like, wow.
Yeah.
I spend my time watching TV. I need to change that.
Yeah. You know, the old question somebody asked Lamborghini, they said, why don't you ever advertise on TV? And they said, our customers don't watch TV.
To the listeners and viewers, if you want a Lamborghini, do not watch TV.
The public service announcement
I know.
for today.
But going back to that, yeah.
Yeah, that willingness to just learn things that are stupid. It's tough. And the further you go in your career, the harder it is.
Yeah.
Because the more frustration you build up with stupid things you learned in the past that didn't pan out.
Yeah.
And I think that's why so many things are invented by kids in high school or college. Because they're just trying everything. And as you get older, you have to really work to be willing to just try everything. And you find things that you're really good at and you focus more on those. And that's good. That's how you build expertise. You still need to take that dash of flavor and try some new things that might not be the next cool thing, that might totally fail. And some set of those things will succeed.
I have another one to throw at you after that.
I had no doubt. I had the shield up already.
I think, okay, now I'm the engineer who's trying new things, or the researcher that's trying new things, or whatever, who I am.
Sure.
Right? I'm trying these new things. What are like my next step? I found a problem I think the world cares about, right? I'm not sure if the world cares about it. Right now I'm in my own little bubble. And I think deep learning is the new solution. It's what people care about. Or evolution AI, data, an AI machine or AI tool that helps data extraction is the new thing that people need. How do I just, you were going to say something actually. I will listen to it.
No, it's good, but nobody's going to like any of my answers.
Why not?
So there's two different aspects of that, right? One is the PhD side of it. The people who go and get their PhDs research a really narrow topic that if they knew it was going to work, wouldn't be that interesting to research. It wouldn't be research, it'd be engineering. So they're going to research a topic for a big chunk of their life that they have no idea if it'll be useful or not. And if it's useful, they will revolutionize the world with that thing. And if it's not useful, they will have learned a ton, but they won't have necessarily built a useful thing. There's another side that is the sort of engineer side or the entrepreneur side, the people who want to make the thing work.
Yeah.
Right? And they have less patience or less interest in the research side of things. And so it's this interesting piece where they're looking for the things people have researched for all this time that they can start to build into something that goes. Both are valid paths. There's nothing wrong with either of those things. But I think one of the questions around that is like, you grab this thing that's like interesting. Are you going to take it a PhD route and go, let's research the crap out of this and figure out if it's a thing, what we could make this thing into, knowing that you might get to the end and the answer might be nope. Or on the other side where it's like, oh, okay, so people have developed this a little bit, maybe a little bit further on, and I can now see the spark of that research, and I think I could make it do something useful.
You know, that just made me think of a story. I don't know if I can tell this, but I remember when I'm the office manager at this company, right? So I was trying to find a way to organize or decorate our office. And I remember I just couldn't find the right color. I couldn't find it, but we have a graphic designer here who's really good at colors, good at design. And I remember I went to Brian and he was like, why are you doing it by yourself? Talk to the guy who knows it. And I think we talk about this story a lot, why we picked pink as our Geyser logo. You know, it wasn't you, it was the guy that knew that pink would work.
Right.
And so like thinking about that, I'm thinking, if you are the one, and maybe correct me if this is not what I'm getting out of this, but it's like if you have the thing and you're not the researcher mode, if you just want to race towards this, make it a product. I think one thing I noticed that Martin worked with a researcher. You know, he wanted to do this product, but he worked with a CTO. Like if you go on their site, if you listen to him talk, he didn't just do that. Like he didn't just do it from his own side. He worked with somebody that knew all the information, knew the customers, knew what they needed, and put this item together. I wonder if you're trying to rush, if you need somebody who knows that additional information to take that stress off of you so you can rush and speed ahead.
Yeah, I think there's the scale at which we can reach as we add collaborators, as we work with other really brilliant people, we scale non-linearly. In other words, if I'm 10 and you're 10, we're not 20 together, right? We're 100 together. So the difference by adding people is really, it's really an impressive thing that it does. And you've got this aspect of people who are engineers building things, maybe software developers, making the things go. But you also have this other side. We talked about this several episodes ago when we talked to Daniel about the farm and this kind of thing.
Right.
Is the other important part is the subject matter experts. Because it turns out I don't know crap about farming.
Right.
And as it turns out, crap is very important in farming. It's one of the most important things to farming, as a matter of fact. And so those subject matter experts understand those things. You can imagine, I mean, the world generally understands some things about farming, but it makes sense if somebody came in and went, this crap, let's get it out of here. Let's throw that away. Well, they would be terrible farmers. And so that expertise to the subject is hugely important to making a thing that actually impacts the world.
Yeah.
That actually makes a difference.
Yeah. I do wonder though, who didn't listen or have a subject matter expert just raced ahead and they got their stuff to shine. I doubt it, but somebody can challenge me on that. I doubt that people who push their product high don't have some customer feedback or don't take the customer feedback or don't take expert feedback. I doubt that it's just your own brain and your own way.
Yeah, I mean, and that makes all the difference. But it's also why you see in the software space so many software engineers building products for software engineers. Because that's what we're the subject matter expert in.
Yeah.
We understand software, so we build tools for software engineers. So that market gets very saturated. Not that you can't invent a great new thing, but so many people are building new things for software engineers because that's the subject matter expertise. That's where you get this huge boost to changing the world by working with somebody who has some completely different expertise than you have, maybe doesn't know the engineering side or the software side or those kinds of machine learning side whatsoever, with someone who does. And now you've got this new influx of ideas and ways of thinking that just change your mind and your mindset in a way that open up brand new worlds of opportunity. Don't forget to like, follow, subscribe, click on our faces, click here, click everything. Thanks for listening.